Today and welcome to video 36. Now today we're going to be doing some harder questions involving sine, tan and cosine and also Pythagoras theorem. So on the board here in the middle I have the sine, tan and cosine formulas, and of course on the corners here we have the Pythagoras theorem formulas. 1, 2, 3, 4 and 5. You see those 5 formulas? Remember, they only work for right angle triangles. So let's get started with our first question. In our first question, we want to find the length of dx. That's this dashed line here. Now, if you look carefully, you will see 2 right angle triangles. A kind of small right angle triangle and then a taller right angle triangle. Here's the plan to find dx. We're going to find the entire length db, that's from the top to the bottom, and then we're going to find from x to b. And guess what we're going to be doing with both answers? We will minus both answers to get the dashed line dx. So at the end of the day, this is the plan. We're going to find the entire length db from here to here, and then we're going to find xb. And when we do that, we will minus both answers. So here's what I did. I took the privilege of splitting this up into 2 triangles. So this triangle is this one, and this one is this one here. So let's label it. Here will be A, B, and X. Okay? A, B, X. A, B, and we're only going up to X. Here will be my 70 meters, and here will be my 30 degrees. We want to find the length of xb. That's this guy here. So let me put my question mark for the time being. It's a right angle triangle. We have one angle on one side. So we need to choose we need to choose the correct formula here. If it's standing up by the 30 degrees, here's the opposite. The side opposite the right angle is your hypotenuse, and this side is my adjacent. Now it seems to me we want to find the length of the opposite side, and we have the length of the hypotenuse. So the adjacent side is pretty much useless in the question at the moment. So we need to choose one of the formulas that has an opposite and a hypotenuse in it, the O and a H. That would be the first guy, sine. So we want to find the length of the opposite side, which is bx or xb. So remember how to use this formula. We block the item that we're trying to find. So we're going to block O. And when we block O, we will be left with hypotenuse multiplied by sine theta. And theta is the angle we're standing up in, which is 30 degrees. So to find the length of the opposite side, all I have to do is take the hypotenuse and multiply by sine theta. My hypotenuse is 70 meters and theta is the angle I'm standing up in. So once again, we just have to multiply these two and we'll get the length of the opposite side, which is xb. So it will just be, let's see this here, 70 multiplied by sine 30. 35. So the length of this side is 35 meters. So that means this length here is 35. We just have to find the length of db now, and we minus both answers. So let's pay attention to the taller triangle. The top of the taller triangle is D, the bottom is B, and we have C. And it seems to me we've been given this angle here, which is 70 degrees, and the length of this side, which is 25 meters. Remember, we need to find the length of db, which is this guy here. So if we're standing up here, this side will be my opposite. The side opposite the right angle is my hypotenuse, which means that this side here is my adjacent. So one of these letters is going to be useless. Remember, we're trying to find the length of BD. Well, DB and BD is the same thing. So it seems to me that the question mark should go here. And we've been given information on the adjacent. So the adjacent and the adjacent and the opposite seems to be very important in this question. Remember, whatever you're trying to find at the moment is the most important thing. So the H seems to be completely useless in this particular question. So we need to choose one with an O and an A. So O and the A. O and the A. That's tan. So we're going to use the tan. And which side are we trying to find? O. So let's block the O. To find O, we are left with adjacent multiplied by tan theta. So opposite is equal to adjacent multiplied by tan theta. Adjacent is 25 and theta is the angle we're standing up in. So let's just type that in our calculator and we'll get the length of the opposite side, which is dB. Let's try that. Let's see. We have 25 multiplied by tan 70. Press equal. 68.69. 68.69. So here we get 68.69 meters. So the length of dB is 68.69. We need to minus both of them to get the length of the dashed line, and that will be our final answer. 68.69 minus 35, and we will get 33.69. This is our final answer for the length of dx. Alright, let's get to our second question. Our second question involves an isosceles triangle. Now, just in case you can't remember, in an isosceles triangle, two sides have the same exact length. And if you look closely here, and notice I have two lines here and two lines here. That means that this length and this length is the exact same length. So if here is 18, then the other side will also be 18 meters. Now we have two things to do in this question. We have to find the vertical height of the isosceles triangle and then find the angle B. What is the vertical height? The vertical height, pretend that you climb the triangle and you're standing at C and you dig a hole here and you drop straight down. When you drop straight down, you'll be falling vertically. So you'll fall like this. And when you fall, notice that this line and this line, you have a right angle here. Now initially, the isosceles triangle is not a right angle triangle, but when you slice an isosceles triangle in half, you get two right angle triangles. You get a right angle triangle on this side and a right angle triangle on the other side. Now once it's a right angle triangle, you're allowed to use the 5 formulas, because these 5 formulas are made for right angle triangles. So let's find the vertical height first. Now, let's ignore this side of the triangle to make it easier. Now, if the total distance is 20, then from here to here is 10 meters. So once we erase 1/2, it's pretty easy. Well, it makes the right angle triangle clearer. It's easier to see the right angle triangle. And I hope you understand how we got the 10 here. The total distance was 20. We sliced it in half. So this side is 10. Let's try to find the vertical height. The vertical height is the dashed line. Now it seems to me we have the length of two sides and we're trying to find a missing side. Remember, whenever we have two sides of a right angle triangle and we're trying to find a missing side, that's the perfect excuse to use Pythagoras theorem. So we're either going to use the red formula or the blue formula. What are we trying to find? Are we trying to find a regular side or the hypotenuse? Remember, the 18 is the hypotenuse. The side opposite the right angle is the hypotenuse. So the other two sides are regular sides. So right now we're just trying to find a regular side. So we're going to use the blue formula. So to find a regular side, you have to take the hypotenuse, which is 18, minus the other side squared, and we square root our answer last. So, to find the length of this side, which is our vertical height, and our vertical height happens to be a regular side, we just need to type in that on the calculator. So I'll see if I can do this for you. Remember, you square root last. So you have 18 squared minus 10 squared. We press equal, we get 224, and then we square root our answer, which is 14.97 if we round it off properly to 2 decimal places. So over here is 14.97 meters. So our vertical height is 14.97 meters. All right, but that's not the end of the question. We still have one more thing to do. We have to find the angle B. That's the second part of the question. Now, we have a kind of particular scenario here. Whenever we are trying to find an angle, we either have to block the cosine, the tan, or the sine, but you have to pick the correct formula first. Usually, one of the sides is be useless, but let's see what happens here. If we're starting up here, here's let's do the hypotenuse first. We know here's our hypotenuse, because it's opposite our right angle. If you're trying to find this angle, then this side is opposite, and the remaining side is adjacent. Usually one of them is useless, but if you look carefully, we're given the length of all, well, not given, we have the length of all 3 sides now. Usually we have to throw away one of them. Here we have all 3 of them we're given information about. We know the length of him, and him. So the truth is, if we choose any one of these now, it doesn't matter. I can close my eyes and just choose one. If I choose one of them, it will give me the correct answer. If I choose this one, it will give me the correct answer. If I choose this one, it will give me the correct answer. But I'll prove it to you. I'll prove it to you. Because this time we have the length of all 3 sides. Let's try sine first. If we're planning to use sine, we have to block the sine. Sine is opposite over hypotenuse. So if we use sine theta is the angle we're trying to find, is the opposite side divided by the hypotenuse. So let's try this one. What's the length of the opposite side if we're starting here? The opposite side is 14.97 and my hypotenuse is 18. I just have to divide these two and the answer I get, I have to sine inverse it. So if we take 14.97 divided by 18, we will get sine theta is equal to 0.83. Throw across the sine and we will get sine inverse 0.83. So how much will be theta? Let's see. Second function, sine 0.83. Roughly around 56 degrees. 56, we'll just call it 56 degrees today, right? So the answer is roughly 56 degrees. So this angle is 56 degrees. But because we have the length of all 3 sides, we can choose any one. Let's just to prove my point, let's choose tan. So I'll put the working for tan over here, so you have something to compare it to. If we're trying to find the angle using tan, tan is opposite divided by adjacent, because we block the tan. So tan theta is equal to the opposite divided by the adjacent. What's the length of the opposite side? The length of the opposite side, if you're standing here, is 14.97. And the adjacent side is 10. So we just need to divide these two. Tan theta, well, if you divide these two, you'll get 1.497. To find theta, we have to throw across the tan to get tan inverse 1.497. So let's work that out on our calculator and see if we get roughly the same answer. Second function, tan inverse 1.497. Press equal. See, we get roughly around 56 degrees again. Now, I know we didn't get the same answer, the exact answer, as when we use sine. That is because we rounded off this answer. Remember, this answer was 14.96 something. If we had used all the decimal places, we would have gotten the same exact answer. But because we rounded off, we only get something close to the answer. Alright? And take my word for it, if we were to use cosine adjacent divided by hypotenuse, the adjacent would be 10, the hypotenuse would be 18. If we did, 10 divided by 18, the adjacent is 10, the hypotenuse is 18. And if we were to divide 10 by 18 and cos inverse it, we would get back something very close to 56 degrees. The moral of the story is, when you have the length of all three sides in a right angle triangle and you're trying to find an angle, you can choose any one of the formulas and any one will give you the correct answer. Alright, so hope you understood everything that went on here today. And of course, if you want a complete listing of all the videos, you can visit the website below and click on free maths videos, and you will go to an area where you'll see all the videos categorized by topics. Alright, so once again, don't forget to subscribe, share the link, and well, have a good day.